Remember we looked at the T formula method to solve equations of the type a sine theta plus b cos theta is c, or you could have a sine theta minus b cos theta is c. In other words, any combination of sine and cos with a constant equals a constant. You can't divide through by cos for these ones. You must use either the T formula method or what we're looking at today, which is the auxiliary angle method. So auxiliary angle means other angle. That's what auxiliary means, other angle. So the other thing is that A, B or C can't be zero to be able to use this method. Sometimes sine can be first with a plus cos, or sine minus cos equals a constant, or you can have cos first plus sine. But of course, cos plus sine is the same as sine plus cos. Or you could have a cos theta minus b sine theta equals c. So any four combinations of the sine and the cos equaling a constant, you can see any questions like those where sine is first or cos is first. Okay, now we're going to learn the method for solving them. The method we will use to solve them is the auxiliary angle method. So to solve equations, for example, if we just focus on the first type, which is a sine theta plus b cos theta is c, to solve those types, so for type 1, for example, to solve these equations, what we end up doing is we write the a sine theta plus b cos theta in another form of r sine theta plus alpha. All right, where alpha is always an acute angle. So that's what we're going to be doing today. And that acute angle, alpha, is always, it's also called the auxiliary angle. That's why this is called the auxiliary angle method, because instead of writing it as a sine theta plus b cos theta, we just want to write it in terms of sine only. So we're going to eliminate that cos, basically. All right. But there are 4 different types that you could be asked. So, and those 4 types are here. All right, so just get that down and I'll explain it in a minute and we'll do some examples on it. You could see 4 different ways they could ask you to express it. If sine is first, if you've got a sine theta plus b cos theta, they will ask you to express it in the form r sine theta plus alpha. Notice the sine one where it's first, it's sine here and we keep the sign the same, plus plus. Another type, a sine theta minus b cos alpha theta, would be the sine type again because the sine is written the first and it's theta minus alpha, keeping the sign the same, minus minus. You could have be asked to do one like the third type where the cos is written first and the sine is written second. Notice the cos is out the front, but the sign is different, theta minus alpha. Remember with sine, we remember sine, keep the sign the same. And if for sine you keep the sign the same, then for cos the sign's different. And the last type where cos is first minus sine, cos is out the front here, theta plus alpha, and you're probably thinking, what is this r? Well, r is the square root of the coefficients of sine and cos, so the square root of a squared plus b squared. And alpha, tan of alpha will end up being b on a. But I don't want you just using that. I don't want you just using that, because if you forget these or something, if you derive it, you never need to learn. It's better that you know how to derive it rather than learning them, because you could just write something incorrectly, all right? So just the proof, just using tan alpha is b on a, so tan alpha is b on a. Just working out that the hypotenuse would be the square root of a squared plus b squared. So I've got a right angle triangle here. Cos alpha is adjacent over hypotenuse, a over the square root of a squared plus b squared. Sine alpha is b over the square root of a squared plus b squared. You'll never really need to do this proof, right? So for example, if I want to prove the first rule that I gave you, which is a sine theta plus b cos theta is r sine theta plus alpha, I'm going to start with the right-hand side because I know what to do with that. The reason I'll start with the right-hand side is that in this triangle, I can only use sine alpha cos alpha, not theta. There's no theta. So if I start with that right-hand side and I expand it, I get r sine theta cos alpha plus cos theta sine alpha, you know, the sums and differences. And r is the square root of a squared plus b squared. It was given in the definition anyway. Sine theta, I can't change, but cos alpha is down there. I substitute. Plus cos theta, sine alpha is down here. Now, when I expand and multiply each term by square root of a squared plus b squared, I just get a sine theta plus b cos theta, which equals the left-hand side. Basically, if you're asked to solve 5 cos theta minus 12 sine theta is -3, when you see that first, you think two things. Either I'm going to use the T formulas or the auxiliary angle method. If they want you to use the auxiliary angle method, they will, in part 1 of the question, ask you to write that 5 cos theta minus 12 sine theta in this form of r cos theta plus alpha. All right, so we're going to start with that. So I'm going to start with the 5 cos theta minus 12 sine theta. They're asking you to write it in the form of r cos theta plus alpha. Okay, keep the left-hand side the same because you can't do anything with that. What can you do with the right-hand side? Expand, sums and differences. You get cos theta. What else? Cos alpha. This one's the cos one. Cos, do we keep? What happens when you expand this? Minus. Now be careful because you get cos minus sine, but r's got to be multiplied by each. Are you okay with that? So I write the r again. R sine theta sine alpha. Now, what I like to do in my next step, so you can go r bracket cos theta cos alpha minus sine theta sine alpha bracket and then expand and put the r in, but you'll learn it's just easier to put the r in for both. Now, what I'm going to do is swap these two coses around and these two sines around. I'll show you why. So that's r cos alpha cos theta minus r sine alpha sine theta. So I'm just swapping them. I'll show you why. The reason is I'm comparing now the left-hand side with the right-hand side. See how the cos theta, that means that this r cos alpha is the coefficient of cos theta. That equals 5. Can you see that? Because I've got r cos alpha cos theta minus r sine alpha sine theta. The coefficient of sine theta on the left is -12, or is 12, because the minuses match up. In other words, the r sine theta must equal 12 and the r cos theta must equal 5. Do you see that? This is why I swapped these two around here in the second line. Do we get it? So now from there we just go. R cos alpha is 5 and r sine alpha is 12. Do you understand why it's not -12? See how we started with a minus and you have to write it in the plus form? The reason is when you expand the cos theta plus alpha, you go back to the minus. That's why you write it in that form. Because now I've got minus and a minus, they match. So I just equate the coefficients of cos theta and sine theta. So why don't I make cos alpha the subject here? Cos alpha is 5 on r and sine alpha is 12 on r. And once you've got an expression for cos alpha and sine alpha, you should draw up a right angle triangle. And where do I put these numbers 5 and 12 and the r? So cos alpha is, where does the 5 go? Adjacent. R is the hypotenuse. Sine alpha, same triangle because it's the same angle. 12 over r. Now you can see why r is the square root of, isn't it 5 squared plus 12 squared? So if you look back at the definition on the page before that we did, it had r is the square root of a squared plus b squared. That's where it comes from. So r is the square root of 5 squared plus 12 squared. All right? Which is the square root of 169, which is 13. It's a Pythagorean triad as well, 5, 12, 13. And so you need to do two things here. Because we're trying to write 5 cos theta minus 12 sine theta in the form r cos theta plus alpha, you've got two jobs here. Work out r and work out alpha. And we're going to plug them in. So tan of alpha is what? So I've worked out r using Pythagoras, and I work out alpha using tan of alpha. So what's tan of alpha? 12 on 5. So alpha is in degrees and minutes, please.
67 degrees, 23.
67 degrees, 23 minutes. So now I can write, so therefore 5 cos theta minus 12 sine theta is, I have to write 5 cos theta minus 12 sine theta in the form r cos theta plus alpha. What's r? 13 cos theta plus, what do I write? 67 degrees, 23 minutes. So now, instead of having an equation in terms of cos and sine, I've now just got an equation in terms of cos. And this alpha is my auxiliary angle. Auxiliary means other angle. All right? Now, how is that going to help me solve this equation? Now I can write 5 cos theta minus 12 sine theta in this form. So therefore, now I can solve. To solve 5 cos theta minus 12 sine theta equals negative 3. So now to solve 5 cos theta minus 12 sine theta equals negative 3, I'm just going to replace my left-hand side with my new expression for 5 cos theta minus 12 sine theta. So so to solve this, now we just solve. So to solve 5 cos theta minus 12 sine theta is negative 3. We just solve 13 cos theta plus 67 degrees, 23 minutes equals negative 3 instead. We solve that one instead. Okay, now this is easy. This is just cos of something equals that number. But remember, we've got a few steps. Cos of theta plus 67 degrees, 23 minutes is what? Negative 3 over 13. And now we use our 4 steps if you want to use the change in domain. Remember, we've got to change the domain. If you're doing anything apart from cos theta, sine theta, tan theta, you've got to change the domain, which is the values of theta. So we want to solve that from 0 to 360. So what are our 3 steps? What's the negative tell me? Quadrants, 1 and 2 and 3. Next thing, acute angle, 67 degrees, 23 minutes. You don't put the negative in. Actually, this may be the only time you can put the negative in, but just don't. So you do shift cos of 3 on 13. Are we okay with that? Just don't put the negative in. The negative is to tell you the quadrants only. The acute angle, theta plus 67 degrees, 23 minutes, what is it?
76 degrees, 39.
76 degrees, 39. Any rounding there, or it's okay?
And then 27 seconds.
It should be okay because you can leave it here because we're not doing theta on 2 and we won't be doubling it or anything. We'll only be subtracting from that other amount, or so it's okay. But remember quadrants 2 and 3, so therefore theta plus 67 degrees, 23 minutes. Quadrant 2 is 180 minus that, 76 degrees, 39 minutes. Quadrant 3 is 180 plus that. Now, we've just got to make sure that these fit in. So what's my new domain? What do I do with this theta? Theta plus 67 degrees, 23 minutes. So what's my new domain? From what to what? So I'm supposed to solve from 0 to 360. But I'm solving now for theta plus 67 degrees, 23 minutes. So don't I add 67 degrees, 23 minutes to these values? That's my new domain. 360 and 60, what's that? 427 degrees. So all my answers when I'm doing this theta plus 67 degrees, 23 minutes has to fit there. Remember, you can draw your little thing too. Well, 67, I'm just going to write 67, 67. That's close enough for my diagram. You know what I mean? So 70, there isn't, that's fine. This is fine. What about next time round? 427. No, it's all good. It's just those two. There won't be any others. Look, because there's your 67. There's nothing there. There's your 360 and another 67. There's none there. Quadrant 2 and 3, it's fine. You're only still going to have those two answers. Anyone got some answers for these? What's 180 minus that?
103.
If you don't want to use your calculator 4 times, wouldn't theta just be that minus that minus that? So you could do that if you just want to use, do you understand what I'm trying to say? So what have you got for this anyway? 103 degrees, 21 minutes. And this one is 256 degrees, 39 minutes. And theta now, we've got to subtract 67 degrees, 23 minutes from each. You can do that. 50
8
minutes and 180.
9 degrees.
Yep.
16 minutes.
Yep. Okay. We're trying to solve root 2 cos theta plus sine theta is 1. Yes, that's of that type. A cos plus B sine is a constant. So to be able to do that, we either use T formula or auxiliary angle method. They're asking us to write root 2 cos theta plus sine theta in this form of r cos theta minus alpha. Hence solve this. So this is auxiliary angle method. So let's start with this part 1. So write root 2 cos theta plus sine theta in the form r cos theta minus alpha. So let's expand. What have we got? R cos theta cos alpha plus or minus? When you expand it, it's cos. We don't keep the sign the same. Plus. Do you notice how that's opposite sign and that's opposite sign? That's why in the first place it started off with the opposite sign. So you've got to, in the expansion it goes opposite. Plus r sine theta sine alpha. What do I do next? Swap those two, swap those two. That's r cos alpha cos theta plus r sine alpha sine theta. And now you can equate coefficients on the left-hand side and the right-hand side. So you can either underline both the causes and you will see r cos alpha is root 2. So cos alpha is root 2 on r. And the sine thetas are the same. So what's r sine alpha going to be? So so the sine thetas are the same. That means the r sine theta, or alpha, sorry, has to be 1. So sine alpha is 1 on r. We then draw up our right angle triangle with alpha. Cos is adjacent over hypotenuse. Sine is opposite over hypotenuse. Therefore, r is the square root of. All good? 1 squared plus root 2 squared, which is root 3. And tan of alpha. So it's always r using Pythag and tan. Tan is, I mean, you could use sine or cos here, but we just use tan because we've already got them. You don't have to worry about whether you've got r or not. Tan is 1 on root 2. That's not an exact value. Only sine alpha 1 on root 2 is. So what have we got? So alpha is, I don't know how many degrees that is. 35. So alpha is 35 degrees, 16 minutes. So now we can say, well, therefore, root 2 cos theta plus sine theta can be written as r, which is root 3 cos theta minus 35 degrees, 16 minutes. Are we good? So we're just using this method to work out r and to work out alpha. And we rewrite the equation now in terms of cos only. So therefore, now to solve, root 2 cos theta plus sine theta equals 1. We just replace, you know what we do now? We replace the root 2 cos theta plus sine theta with root 3 cos theta minus 35 degrees, 61 minutes equals 1. And that's what we're solving now, which is something we know how to solve. So part 2 of the question is to solve root 2 cos theta plus sine theta. The purpose of part 1 is to write root 2 cos theta plus sine theta in another form with only cos. So hence, to solve that, we just replace the root 2 cos theta plus sine theta with our new expression for it, using the auxiliary angle. And now it's just solving an equation just in terms of cos. So we've got cos of theta minus 35 degrees 16 minutes equals 1 on root 3. And we do our steps. 3 steps. With the domain change, it's 4 steps. We're solving from 0 to 360. So we've got theta minus 35 degrees 16 minutes. So we've got to subtract 35 degrees 16 minutes from each of these. So that's a negative 35/16. And 360 minus 35, what's that? 325, but it's got to be 324 degrees 44 minutes, is it? So that's your new domain. All right, what are your steps? Quadrants. Quadrants, which ones? It's positive, 1 and 4. So you've got to be careful when it's 1 and 4 because this negative 35 is in quadrant 4. We've just got to see if it fits in or not. And next step is your acute angle theta minus 35 degrees 16 minutes. So cos of that is 1 on root 3. So it's just shift cos 1 on root 3. 4 degrees, 44 minutes. So now we write out our solutions, just doing a quick sketch. Quadrant 1, 54 approximately. Quadrant 4, 54. Now, we are only allowed to go, let's do the negative angle first from negative 35. Does that fit in? It doesn't fit. If I go back negative 35, I've got negative 54 here. That's outside the domain, so I don't need to go to the negative side. What's my first one that fits? So theta minus 35 degrees 16 minutes. It's the 54 degrees 44 minutes for quadrant 1. And this one should fit in 324. And it'll be 360 minus 54 degrees 44 minutes. So your two answers there are 54 degrees 44 minutes and 305 degrees 16 minutes? And that's what theta minus 35 degrees 16 minutes is. So now what do we do? Add. So theta, you need to add 35 degrees 16 minutes to each of those. So notice my domain, minus 35, that doesn't fit. Minus 35 is up to about there. That's not going to be one of the answers, so just coming around this way. And those two answers fit from 0 to 324. Or from negative 35 to 324. What have we got when we add 35? Oh, it goes to a whole, oh, 90 degrees and?
340 degrees 32. 340.
Okay, good. And you can have a quick look. It's really good to see that 91. Let's just have a look and check that it's okay. All right, I'm just going to, we know that these are our answers, but let's just check. Root 2 cos of 90, it's just that cos 90 is easy to do, plus sine of 90. What does that equal? Let's draw the cos curve. What's cos of 90? 0. And sine of 90? And that does equal 1. Because the equation is meant to equal 1. See? Cos theta is 90 is a solution. And I'm not going to check the other one. All right? 4 sine theta minus cos theta in this form. So 4 sine theta minus cos theta in the form r sine theta minus alpha. Notice it starts with sine. This one starts with sine, and this is a minus, that's a minus. Keep the sign the same. Be careful with the expansion for sine. What is it? Sine theta. Is it sine sine or sine cos? Sine cos, sine theta cos alpha. Keep the sign the same, minus r cos theta sine alpha. I do my swap again, which is r cos alpha sine theta minus r sine alpha cos theta. Why do I do the swap? So that I can see these nice and easily. Sorry, that which ones match up with each other. So we can see that R cos alpha is 4. In other words, cos alpha is 4 on R. And we can see that, now notice that's minus, all good. R sine alpha must be 1. So sine alpha is 1 on R. You should not get that this is a -1. If you've got a negative, you've done something wrong in the expansion, or you've written the question out wrong, or you've done something wrong. All right? So that's a 1 on R, and R is the square root of 1 squared plus 4 squared, square root of 17. And tan of alpha is opposite on adjacent, which is a quarter, and you can work out what alpha is. This was 14 degrees 2 minutes. 4 sine theta minus cos alpha. Have to write it in the form R sine theta minus alpha. R is root 17 sine theta minus 14 degrees and 2 minutes. And the question is to solve. Therefore, so for part 2, to solve 4 sine theta minus cos theta plus 3 equals 0. This one's written slightly different. It doesn't matter that the plus 3's here. Just take it to the other side. Right? So to solve that, we replace the first 2 terms with our expression, root 17 sine theta minus 14 degrees 2 minutes plus 3 equals 0. We just make sine theta the subject. Sine theta minus 14 degrees 2 minutes the subject. And what's that going to equal? Anyone? Good. -3 over root 17, which quadrants? And acute angle. And you can, so you're going to have to work out your acute angle and your quadrants, and you're going to have to work out your new domain, because it's from 0 to 360, as stated in the question. Well, it was, sort of. And you've got to subtract 14 degrees 2 minutes. 360 minus 14, 345 degrees 58 minutes. So we've got quadrants, negative, quadrants 3 and 4. Anyone got the acute angle yet? Shift sine of 3 on root 17. So the acute angle is 46 degrees, 41 minutes. We're in quadrants 3 and 4. I'm just going to write 46, close enough, like on the diagram. Okay, so if you've got to go back -14, you don't hit it. You don't hit -46, so that's okay. We're just going around positive direction. Therefore, theta minus 14 degrees 2 minutes is equal to, we've got quadrant 3, which is 180 plus 226 degrees 14 minutes. And for quadrant 4, we've got 360 minus, is that 313 degrees? 19 minutes. And now what do? Add 14 degrees 2 minutes. What's that? 240 degrees, 16 minutes. 327 degrees, 21 minutes. Sine theta plus cos theta in this form of r sine theta plus alpha, and hence solve this equation. So sine theta plus cos theta equals r sine theta plus alpha, which is r sine theta cos alpha plus, keep the sign the same, r cos theta sine alpha, swap them around, r cos alpha sine theta plus r sine alpha cos theta. You can equate your coefficients. So r cos alpha is, what is it? 1. R sine alpha is also 1. That means cos alpha is 1 on r. Sine alpha is also 1 on r. Drawing up our right angled triangle. R is the square root of 1 squared plus 1 squared, which is root 2. And tan of alpha is, oh, this is a nice one. What's tan of alpha? 1 on 1, which is 1. So alpha is 45 degrees. So that's a good one. So therefore, sine theta plus cos theta in the form of r sine theta plus alpha is root 2 sine theta plus 45 degrees. And the second part of the question is to solve sine theta plus cos theta equals -1. To solve sine theta plus cos theta is -1, we're really solving root 2 sine theta plus 45 degrees equals -1. So the sine of theta plus 45 degrees is -1 on root 2. Oh, this is a nice exact amount. Well, this one's going to be a bit funny. So, what's the new domain? We're adding 45. So we're up to 405. So what have we got? Quadrants. What quadrants? 3 and 4. What's the acute angle for theta plus 45? Sine of what is 1 on root 2? Sine of 45, isn't it? So therefore your two solutions for theta plus 45 are in quadrants 3 and 4. So it's 180 plus 445 plus 45, which is 225. So I'll just do the sketch here. And the other one will be 360 minus, which is 315. Now, do we keep going round? Like we can, we start from 45, we stop at 4 or 5. There's nothing there in quadrant 1 anyway. So therefore theta is, you subtract 45 from each of these, 180. So this is one of them where if you use T formula, the T squareds would have cancelled and you would have got a linear equation. And when the T squareds cancelled, you eliminated your theta is 180 degree solution. See, because when you use the T formula, you end up with a quadratic. And if in your working out you lose the T squared, you've eliminated it. So that's why you've got to check for 180 if T squared gets eliminated when using the T formula. And 315 minus 45 is 270. And those are really easy to check if they're the answers, because this is the question, sine theta plus cos theta is -1. And by doing, so I could just check them if I wanted, by doing a quick sketch of sine and a quick sketch of cos, you can see sine of 180 is 0, cos of 180 is -1. That works, 0 plus -1. And if you look at the 270 results, they're the bigger circles, the 270 results, sine of 270 is -1, cos of 270 is 0, and they both work. Do you see that? So when the answers are like 90, 180, 270, you can check them, all right?